Welcome to the Comet ML office hours. I'm your host, Harpreet Sahota. It is Wednesday, the 26th of January. Super excited to have all of you guys here. We've got a amazing panel discussion that's about to go down. I, for one, am super pumped about this. Before we get into introducing our panelists, though, I want to take a quick second to just share something with y'all. As you guys know, we've been doing this series for the last 4 weeks. Is the fourth week that we've been doing this, and it's just all about standardizing the experiment process, the experimental process for machine learning. So we've been talking at a high level conceptually about a lot of these concepts, but we wanted to do something to show you guys all of the stuff in action. So again, just what are the 7 steps to standardizing the experiment? Well, first step is to define scope and success criteria for your project. Second is creating baselines. Third, which we're going to talk about today, is all about understanding and validating data. Then there's also data pre-processing, feature engineering, iterating over different model types, hyperparameter search and fine-tuning, serving the model, and then also monitoring model production when it's in the wild, when it's deployed. So we've been having a bunch of blog posts to accompany each session along with awesome speakers, but we've also got hands-on working sessions where you can check out how all this stuff looks like in action. So definitely go to the Comet YouTube channel. We've got 3 working sessions up so far, led by my colleagues Drew and Michael. We've got code examples and examples for how to set up your project. A lot of great resources for really setting yourself up for success. So definitely check that out. If you go to the video, all the accompanying code will be there for you as well. There's going to be a link to a GitHub. So definitely check that out. We'll be sure to leave links for that in the chat here and also in the comment section of LinkedIn. All right, so let's go ahead and get started. I'm excited for our series today. We've got an epic panel. So our first panelist loves to solve real-world problems with machine learning and AI. He's an ML developer advocate at Pachyderm, where he focuses on creating a great data science experience and sharing best practices for how to use Pachyderm. He's received his master's in computer science from the legendary Oxford University and previously was the director of applied research at Digital Reasoning, where he led research and development efforts on speech recognition and NLP. When he isn't at work, he's either playing music or trying to learn something new, because you suddenly understand something you've understood all your life, but in a new way. Please help me in welcoming to the panel our first panelist, Jimmy Whitaker. Jimmy, thank you so much for taking time out of your schedule to be on the show today, man. I appreciate having you here.
Thanks so much. Appreciate it.
Our next panelist is deeply committed to unlocking human potential with technology and does so by building teams that ask the right questions and systems that get the right answers. Not only has he earned a PhD in public policy, political science, and complex systems from the University of Michigan, he's also an experienced product engineering leader with expertise in the modern data ecosystem, open source community development, and early and growth stage entrepreneurship. Today, we get the opportunity to pick his brain on all things data quality, from data testing, documentation, and profiling. Please help me in welcoming to the panel the CEO and co-founder of Superconductive, the company behind Great Expectations, whose mission it is to revolutionize the speed and integrity of data collaboration, Dr. Abe Gong. Abe, thank you so much for taking time out of your schedule to be on the show today. I appreciate having you here.
Thanks for having me. I don't get introduced as doctor a lot. It's fun.
Our final panelist wears multiple hats, from data modeler to data analyst to data governance analyst. He's passionate about Python, AutoML, machine learning using Spark, and all things mathematics and statistics. He's got 5 years experience working in data science and analytics and is currently a data governance analyst at Brinks Home Security. At Brinks, he works closely with their sales, marketing, and finance teams to improve products and services for their customers using advanced analytics, creating and maintaining data models, and improving data quality. He's got experience creating data models from user requirements, creating model documentation, improving data quality, and providing support for data engineering efforts. Please help me in welcoming to the panel, community member and good friend of mine, Matt Blasa. Matt, thank you so much for taking time to join us today.
Hey, nice to meet you. Pleasure being here.
All right, here we have it, y'all. We got the panel going on. I'm super excited for this. I think something that's really easy to forget when you're building models is that the data you're using is generated out in the real world, is captured by systems, and goes through a number of processing steps. What I'm hoping to do with this panel discussion is help connect the different pieces of expertise we have here to the overarching theme of ML ops. So as a high-level overview, ML ops is about accelerating the development, production, and deployment of machine learning models while ensuring the quality of model outputs. But we can't have quality model output without quality model input. And for machine learning, that input is data. It all starts with data being captured and ingested from the real world before being cleaned, transformed, stored. That's what we're here to talk about today, the importance of good quality data and good practices with data for machine learning, and how we can make sure we're setting ourselves up for success by ensuring that our data quality is good. So I get confused by all the terminology that's out there: data governance, data quality, data validation, data pipelines, all these different terms. I'm wondering if we could help kind of get some definitions around this, starting with Matt. Matt, talk to us about what data governance is all about and the importance of data governance for the machine learning process.
Yeah, I mean, data governance at its base is ensuring the quality, the integrity, and security of and the ability to use the data collected by the organization. So by the end users be able to use it, and is the data that we are using to build machine learning models or even a dashboard, is that quality, and can that generate the insights that the business needs to move the bottom line or to generate value? I mean, it's pretty broad. That can include everything from how to handle private information, what information to delete, to as far as documenting data models or machine learning model explainability. So, I mean, the main importance to it is for just the foundation. It's the data quality, knowing what the high quality data is. I mean, errors in one data set can affect your machine learning model, can totally mess it up. So it helps being able to trace it, or if you need to debug it or look further stuff in the pipeline. Data lineage, making sure that you know what the transformations were, what was the path that the data took to there. And also legal and ethics, just to be able to make sure that, hey, is the data that we are using, can it be used for prediction, or can it be used for predictive analytics, among other things. And lastly, reproducibility. It allows you to reproduce the models, and it gives you a context of the data environment in which the model sits.
Thank you so much for that. Jimmy, can you describe what data pipelines are all about, and maybe talk to us about the importance of versioning data, versioning pipelines?
Yeah, sure thing. So data pipelines, if we start there, like data pipelines themselves, really you're just trying to transform data from one state to another. But normally it's not just a single transformation that gets you there. So there's multiple things that you need to do, whether it's normalizing your data or filtering some things out, or all kinds of different things that you may want to happen. So they're usually many steps, and sometimes there's forks along the road. So we usually refer to these as pipelines, and a particular workflow is how you're stringing these different stages together. Data versioning, so that's data pipelines. Data versioning is, I think, typically kind of, even in the context of these conversations, treated as kind of a separate component or kind of a different topic. And I think this is kind of unfortunate, because I think data pipelines, in particular on the machine learning side, and versioning and data versioning are kind of tightly coupled, or they should be. And the main reason for this is, as you're transforming your data, you want to know what transformations you've applied to your data, or like what the end effect of those transformations were. Because if something went wrong, you want to go back and look at the previous version. Because ultimately machine learning is a science. And so as much as you can keep a track record of all the different things that have happened in kind of this infinitely complex process, which is machine learning, then you have a much better chance or a much better approach when you want to find out where something went wrong, or did this transformation, did this pipeline produce what we expected it to? And then how do we kind of chase it back up the chain to improve the process to make sure that we're getting to where we want to.
So thank you so much, Jimmy. Appreciate that. Now let's get into data testing and validation. Abe, talk to us about that. Why should we be testing? I guess, what is data testing? Why should we even be testing our data? And kind of like this concept of unit tests for data.
Yeah, I actually feel like Matt and Jimmy have like done a beautiful job setting this up, because like Matt's talking about data quality and kind of at its heart, having multiple stakeholders who all need to ask questions of the data and be able to trust that it does the right thing. And then Jimmy, I think you're pulling out the like natural complexity that builds up in pipelines. Like they change over time. Your data vendor will send you different, like all kinds of things can change in that system. So data testing is really about maintaining trust while still being able to change, right? And not just being able to change, knowing that things are going to change in the real world. And then knowing that your system also will grow and adapt over time and kind of like get more nuanced, be able to ask more questions. And practically speaking, the only way to do that in a scalable way is to automate a lot of the testing. And by that, I don't mean, some magic anomaly detection that knows all the things that you were supposed to know. Like that, practically speaking, really never works. But instead, it's taking specific questions that you were asking already and delegating them to the computer. So when you talk about data validation, I'm coming from great expectations. So, everything's framed in the language of expectations. But at this point in our pipeline, we expect this column to contain no null values. If that ever changed, I'd want to know about it. So computer, please, take over the asking of that question for me. So trying to weave the threads together, because it's, there are a bunch of moving parts.
Yeah, definitely. I love that. I love how we're kind of connecting this all end to end, really, right? So let's think about how all these different terms and concepts that we've discussed connect to this larger context of ML ops. So Matt, can you talk to us about the role of data governance in the machine learning process, as well as how or if it fits into the larger context of ML ops? And also, all you guys watching on LinkedIn, all you guys in the chat, if you guys have questions, please do let us know. Drop it right there in the comment or in the chat. We'll be sure to get to them.
Yeah, I mean, for me, like the data governance process, it's from end to end. So, I mean, you're governing it from the time that it's been ingested to the time that you output it. So wherever that output would be, whether it's an analytics, whether it's a dashboard, or whether it's a machine learning model, and also like what the use cases of that are. So we need to make sure that that what we're using is correct, that it's answers the question that the business is looking for, and is using the correct data and transforming it in the correct way and hiding customer information that's not useful to the end users. So, I mean, as far as like who needs to be involved in it, since it's an end-to-end process, I feel like everybody should be involved into it. Otherwise, the data governance starts risking being focused only on what each individual thinks it's important. So if you had a data scientist, they're going to focus on model explainability. If you had a data engineer, they're going to focus on, hey, we're looking at like anonymization of data, and I've seen this too, just totally putting a huge SQL query in the business logic. So for me, everyone should have an input in the process, not totally govern it and not totally be like responsible for it. And in that regard, it's good to have a data quality manager or a data quality analyst whose sole job is to organize all that data, be able to act as an intermediary, or in a manager, a referee, to make sure that all the data is being captured and side details aren't being included into a governance document that's meant for consumption by all users, from the business user to the tech teams.
Thanks so much. Jimmy, let's try to loop that question in much in the same way, because I guess data doesn't move from place to place on its own. It's usually pumped along through some pipelines, through code and some other infrastructure. Can you talk to us about how all of this fits into the bigger picture of ML ops?
Yeah, so data itself, like you're right, it didn't move from place to place on its own typically. Something's got to facilitate that, and the logic to back that is sometimes complex, and sometimes it's very, very scripted together and brittle, I guess I should say. So, so yeah, and like this kind of segues into Pachyderm, because like I work there because I want to make this process much easier and solve some of the problems I've had at previous organizations. But the main difficulty here is like, I think we know generally in the software community how to use code, how to build things with code to automate things from a code perspective. Like CI/CD is the normal kind of thing that we think of on like a testing framework side. And those tests can be like really small and really simple, or they can be pretty big on an integration type test or scale test or something. But then when we get to machine learning, data kind of throws a curveball into a lot of this. And so what you're looking for sort of is some way to get all the things that you need out of kind of a CI/CD process that you see inside of like GitHub, for example, and want to be able to apply that somehow to data. So you get into some considerations where you need this efficient data storage, and how are you going to scale out like pipelines and these kinds of things. And then how do you make this, how do you build something like this that can scale with your data? And the data is always going to be growing. It's usually of different types of files and all kinds of other things. And then the flexibility to apply code to it. There's a lot of complexities, I guess. So as far as how that fits into MLOps, I think there's a lot of parallels in, or like MLOps in general, I think is a lot of trying to do what's been done in the software industry and take these general principles and then apply them to the moving parts that are inside of machine learning, which the moving parts there are your code, your data, and then what I kind of refer to as like your code plus your data, like where those two are actually meeting, which is usually inside of a pipeline, but then that also touches infrastructure and some other things. So there's a bunch of moving pieces, but then the convergence point of those things, I think, is MLOps, and then how to kind of operationalize that, do it in a standard way, so you're not having to have it be a manual process all the time.
And this might be kind of a naive-ish question, but I'm wondering, what's the difference between data versioning and data lineage? It sounds like they are the same thing, but intuitively, I'm thinking they're probably not.
Yeah, so data versioning, usually kind of how I think about it is usually data versioning is really like the snapshots. It's the what. It's like, what is our data in this particular state, or what does it look like at this point in time? And then lineage, I think of it as the how, if you will. So if versioning is the what, like this is my version of my data, lineage is how did the data get into this state, or like this snapshot is the result of what. And so it's lineage, I think of it as the how data has changed over time, what's happened to move it from its raw state to the process state that you see now. So that can include knowing what pipeline had run to transform it from raw to this now pre-processed version or something like that, et cetera. But yeah, so that's kind of how I think about data versioning versus data lineage. One has a story around it, the how, and the other one is just kind of what is captured there.
And we think about the different characters, like on a standard machine learning data science team, you got the data scientists, we got data engineers, machine learning engineers, so on and so forth. Who on this team should take the main responsibility for this task of, data versioning pipelines? What were your thoughts around that?
Yeah, so I think the main characters, I mean, in general, it's always good to have everyone be aware of data versioning in the respective capacities. So knowing that just having everyone on the same page, data scientists, data engineers, everybody, that they need versioning and lineage to be able to do their work well. I think there just needs to be a general knowledge for sure. But how their organization is approaching their versioning and lineage, or what kind of things are they willing to sacrifice or accept for their particular environment. But in general, I think it's data engineers probably need to be most concerned with the day-to-day operations of the data. Data scientists, I mean, it's kind of like the handoff points that Matt was talking about a second ago, that it kind of falls into different categories. Like data scientists need to know what version of data they're training a model on so that you can reproduce your experiment, or something like that. Data curators, ideally, if you're labeling data, Hopefully they don't need to know really much about like the underlying infrastructure and how to version things and all of that, as long as they're able to iterate on that data and then provide consistent releases to whomever the person that, or the team that's interested in that, then that's, they just need to be aware of the downstream implications, really, is kind of the main thing. So I think there's some different roles, and they all need to be generally aware that versioning is important and things are going to be versioned. But to the extent that it's not too much cognitive load, if you will. Like, you don't want to completely overwhelm somebody with having to know all of the intricacies of everything that's happening inside your org, because then you can't concentrate on the problem you're actually trying to solve. And so, and you know, shout out, I'm sure we'll get here in the course of this conversation, but that's where tooling, I think, really comes in. The more you can trust your tooling, then the less you have to depend on people to keep everything in their heads. And we're all error prone. And I'm sure Abe has plenty of thoughts on this.
On being error prone? Yeah, totally.
Sorry, no.
Definitely. Before I get to Abe, though, I'm curious. You mentioned something or kind of a role or function in there that I've heard recently kind of enter the vocabulary for data science professionals. And that's the data curator. What exactly is a data curator? What skill sets do they possess? Who would be a good fit for this? Is this, something you can go to boot camp to become? Jimmy or Abe, both of you guys look like you guys have thoughts on this. I'd love to hear your thoughts on this data curator.
I've been talking a lot. You go ahead, Abe. I'll jump in after.
I'm thinking of a talk that Emily Shario, formerly from Netlify, now at Amplify, gave a while ago, a couple months back, on the evolution. Basically, she was making the case that we should get rid of the title data scientist and sort of explode it into a bunch of different roles. I don't know that the exact roles she was pointing to are the right ones, but the notion that data science, like from the beginning, data science was sort of this unicorn role that was responsible for doing a million things all at once. And I think what's happening now is tooling is moving really, really quickly and making it possible to differentiate those roles, differentiate the process. So actually, let me pull up a picture. The way that I've come to think of it, because I think the specific tools are still in flux, and so it's hard to nail it down. But the way I've come to think of it is there are two important skill sets. There's domain knowledge, and then there's repeatability and automation. And what you're looking for when you're kind of building roles and building an organization is you're trying to make sure that they have enough overlap, but not too much. Because if you have too much overlap, you wind up in the place that Jimmy was talking about, where like people just have to know all kinds of arcane details about how the data system works, and it's too much and it's too hard to hire for. But if there's not enough overlap, you end up in this place where the data systems are really brittle. And I've seen organizations, I actually think there are many organizations where there are important data processes where nobody actually knows how it works, right? Like, and if you were going to try and track down, like, okay, how do we go from, somebody swiping a credit card in the real world to all the way through the data system to, how this dashboard gets populated? It's actually not that unusual to discover that supply chain isn't secure all the way. And that, there used to be a team that managed this, but now they've shifted over here and that one person left. And so if you were going to figure out how your own data pipeline worked, it'd actually be archaeology, right? Like not a more managed process. So I think we're kind of coming out of those dark ages now, but that's still very, very common for a lot of data teams.
Yeah, definitely agree with you on that, because data science is kind of like a broad umbrella term, broad umbrella category, right? Like if you tell somebody you're a software engineer, okay, well, front end, back end, what type of software engineer are you? I think data science is that umbrella category, and within that category, we have these different roles and different personas. Thank you for that. Jimmy, what are your thoughts on this role of the data curator?
Yeah, so and this one's more of a practical example, or how I think of it. I realized when we were working on, for instance, speech recognition models, that the research teams were really focused. We wanted them to be able to focus on research. The data science teams were applying the research in the real world context. And then it's pretty much, we would always have speech recognition models. You're going into, in our case, financial institutions where you might have multiple languages, accents, all kinds of other stuff. There would always be gaps in the model's capability. And so what we would have to do is say, okay, now data curators or people who are kind of our data strategy team, how do we actually get data to cover or to improve in these areas that we're struggling? And so that process, we were always trying to divorce it from the data scientist workflow. We wanted them to be able to feedback something to, in this case, data curators, or the people who are concentrated specifically on getting high quality data and releasing that in a regular cadence where it could be consumed downstream. And there would have to be, you want those conversations to, as much as you can, be on the consistency of the data and the quality of the data, and less so on just the logistics. And so that's yeah. So like basically you're trying to free up the teams where communication is that's really valuable. You want good communication between the teams, but you want them communicating on the quality and not on the logistics of everything that's going on. But yeah, I would say data curators should be kind of concentrated, or it's a particular concentration, I guess, of trying to get high quality data that's going to improve your model in a particular aspect.
Can I ask a follow-up on that?
Yeah.
Jimmy, I don't know if you're following the data mesh community and the kind of their exploration around the notion of what is a data mesh and what is a data product within that mesh. Are you tracking that conversation? Because it feels overlapping, but not identical to what you're describing.
I've seen it go by. I haven't dove in on it specifically though.
Got it. The thing that I think is maybe a connection point is this notion of you're not just producing tables in a data warehouse. You want to think of that as a product, and product in the sense of it's a thing that has users and has to have certain affordances to make it easy for those users to use it. And so when you describe a curator, I hear a similar thing, right? You're curating it for somebody, with kind of specific agreements in mind.
I think that's absolutely right. Like at least how we were trying to structure things or structuring things was we would want to have, like, it was almost a product. You were releasing a data set, or this is version 2 of our Portuguese accented like financial terms, blah, blah, blah. Like it is almost treating it as a product, or these data sets are releases, and knowing that just like software, they're going to grow and change over time. And there are going to be more types of product releases for new capabilities and stuff like that. So I think that's exactly right. I'm more involved on the unstructured data than the structured data, but it's great hearing that it sounds like that's becoming more normalized in the structured community as well.
I think so. I think the language and the exact roles are still in flux, but the notion that there's something there, I think that's gaining a lot of momentum.
Cool. Love that.
Definitely something to check out, Data Mesh. Abe, if you have any resources that you'd like to share, please do drop a link in the chat. We'll be sure to disseminate that. But Jimmy had a good point there. Data changes. Things, in production don't necessarily line up with what you might have trained with. So I guess before data even gets to our model, we need to ensure that it meets expectations. So talk to us about how data testing, validation, and documentation fits into MLOps.
Yeah. So the way that we think of it with Great Expectations is we really want to be a shared language. And I think one of the things that was not obvious when people talked about data quality, say a year ago or 2 years ago, was that it's really like a multi-stakeholder thing, right? All of the conversation we're having here is about how multiple people all need to coordinate on what the data means and how it gets processed. So the role that we're trying to play with Great Expectations is to have this notion of tests that can also be documentation, and tests that can execute across lots of different backends. So you can run the same expectation in SQL, many different dialects of SQL. You can run it in Spark. You can run it in Pandas. We don't officially support Dask yet, but it's close enough that people actually use it for in Dask. And so the notion, the way that we think of it is you want to be able to have these assertions about data that everybody can be confident are true. And in order for everybody to be confident, one, they have to execute the same way in lots of places. And two, you've got to be able to translate that into whatever language people are speaking. And language here could be Python or SQL, but it could also be a Slack message or a static HTML site where people can see a data dictionary. So,
And
just to kind of put a bow on that thought. So, if you imagine these pipelines, we think of this as checkpoints, or we're starting to use the language of data contracts. It's like a contract between parties along the flow of data through the data pipeline. And the important thing about a contract is it has to be in a language that everybody speaks. And one of the things you run into with a lot of data teams is the data warehousing team is, very fluent in SQL, but barely touches Python. And then when you go over to the ML team, it's all Python and maybe Spark, maybe Scala, right? And so being able to be polyglot and translate between those things at the important junctures is kind of like the unique capability that we bring to the table.
Awesome. Thank you so much for that insight there, Abe. I guess what's the relationship between data quality and data validation? Are they the same thing, two sides of the same coin, or just different altogether?
I mean, they're words, right? So at some level, it's semantic, but I think the best definition for those is to say data quality is kind of whatever is required for people to trust the data. So pretty broad definition there. And then data validation is the subset of those things that can be delegated specifically to automated checking, right? So for just to give an example, think about PII detection, data loss prevention. At some level, so there's quality, like, are we leaking data about our customers or users that we shouldn't be leaking? That's the quality level question. And when you think about how you reduce that to practice, some of that is, well, we're going to have people who understand the legalities about quality actually go through and verify. But when you look at what it takes to verify, they're going to be running a lot of queries. They're going to be inspecting the data itself. And a lot of that inspection can be rolled up and automated.
And when we think about the characters on the data team, like, we talked about the scientists, the data engineers, ML engineers, when it comes to ensuring expectations for our data are met and that we have good data validation practices in place, who should be responsible for that aspect of the work?
So I don't think there's a one size fits all solution there, because it depends on org structure, and organizations are still using titles differently, and I think probably will for a number of years. And it also depends on your architecture and the tools that you've adopted. So I don't think there's a one size fits all answer for that. What I will say, practically speaking, in the Great Expectations community, and just for reference, this is like several thousand data practitioners who all care deeply about this stuff. What we usually see is it's the downstream consumer of data who puts data quality checks in place to make sure that they're not going to get thrashed by upstream changes in the data. And it's sort of defensive, right? Like, it's making sure the data that enters in your borders, like you know what it is and you can vouch for it. And then the more forward-minded teams, at which it just depends on how fast you can move, eventually start putting quality checks as they send data out. And that becomes kind of their contract, their data contract with downstream consumers. So, what are the job titles of people there? All over the place. It depends a lot. But it's almost always somebody who's at the juncture of domain knowledge and repeatability. And I'd say 2/3 of cases, it's people defending against bad data first, and then giving us stronger SLA for their users. Sometimes it goes the other way around too.
Thank you so much. If you guys have questions or comments in the live session here, feel free to let us know. Also, if you're watching on LinkedIn or on YouTube, if you guys got questions or comments, by all means, do let us know. I guess we want to try to make all this more tangible, less abstract. So I was hoping maybe you could share either from your own experience, some case studies that you've read online, or maybe just a hypothetical situation, a war story where maybe Matt, a war story where lack of data governance caused issues for a machine learning project.
Oh, I have a good one for this one. So when I was doing client work on the side, so one of the clients I worked with was an electrical meter company. So they switched from having their techs hand record like the meter readings, which were on a dial system, to a actual like sensor that collected the data and then sent it through 5G. We were trying to do model predictions on it, and then we found out that the predictions were way off. There was like the accuracy was low, the mean square error was bad. I mean, it was just completely off. It wasn't even functional. And this wasn't even deployment. We were experimenting. So what we found out was it again goes back down to data quality. The predictions were way off because there were different ways of collecting it. The sensor only saw what the sensor could see. The sensor said, okay, this is it. And it was pretty accurate when we checked the sensor data. But when we checked how the people who were hand recording it were, people were reading the sensor readings different because they were a dial system instead of a digital system. So we ended up trying to segment that. So we have to segment all the dates where before a certain date, this was all, we had to create two models. So one model for, hey, these were when people were doing it by hand, and then this was after the sensors were doing it by hand. It was a little more complex than that because no one ever replaced all the sensors at once. We had a certain threshold to say, okay, at this point, 60% sensor, so we'll use the sensor model. At this point was 60% people doing it by hand, so we have to use the model based off the hand. Because the training data was having, the initial training data was having both flooding into it. So we got completely inaccurate predictions when we experimented with it.
Yeah, Matt, thank you so much for sharing. That's an important point. I guess it's maybe global model performance is not as important as model performance on segments or slices of data, depending on the use case. Jimmy, I was wondering if you could share a war story where lack of version control for data pipelines caused the model to melt.
Yeah. So this one I've experienced firsthand. It's more of an oddity, but you can extrapolate some of the potential issues that would go wrong. So in the case of speech recognition, digits are a really interesting thing. Like in transcripts, for example, like if you receive a bunch of transcripts and audio pairs, which is your training data from someone or from like either an organization that curates stuff for you or that you do in-house. And you need a lot of that as well. But like standardizing how people write things, like in the financial markets, like $1 or dates are a particular one, like 2022 or 2022. Like there's multiple ways to say it that all map to a single thing, or can all map to a single thing, or do you represent it as the spoken version, like 20 spelled out, 22 spelled out, because you're seeing more like speech to character kind of data in that scenario. So there's some interesting things that you can get just from a data perspective, and inspecting all the data is sometimes too much. If you're getting thousands of hours of audio coming in with transcripts, you can't spot check everything. So essentially the war story here was we were doing kind of full end-to-end deep learning stuff, like sequence to sequence type modeling and those kinds of things back when, like 5 years ago or something, and actually longer than that. Wow, that's getting scary thinking how far back that was now. But essentially what we received a bunch of data and just ran our pre-processing on it. And we were using basically converting digits to the spoken representation, like spelled out 2022 or something like that. And so what was really interesting was obviously no errors in our model. This pre-processing is happening on like this guy gets into Abe's territory as well, potentially. This is happening on your training data, this is happening on your testing data. So you have this processing that goes across everything, and using this data for however long, not seeing any issues because, consistent releases of models. And then one time we were inspecting something, or we had a new piece of data that we were trying to see how well we could do on this one audio clip, for example. And the person said, back in 2016, and we saw that the model had spelled out 2016. And we're like, well, this is kind of odd. Like we would expected, like they said one thing and our model inserted a lot of words that weren't there. And it's also a character-based model at this point. And so to insert that many letters in a sequence to sequence model is pretty interesting. And so then we had, at that point, we're like, okay, something's going on in our data somewhere. How do we find this? And how much of it is present in our data? Because we knew that we had run these transformations over all of our data, but now we didn't know when this new data, or when that new data, what new data actually impacted. When did something come in where everything changed and how many releases of the models had happened before we found this out, because it was the same pre-processing as you should, like same pre-processing on your input data, or sorry, on your training data and testing validation data. But yeah, we were seeing the model it's going to learn whatever it can from the data, and learning the transformation of the spoken word 2022, for example, to 2022 was really interesting, that a deep learning model could learn that and and just know it. So that one's the one where we found, oh, like the version control, we can't just like version the releases of the data sets and stuff. We also need to know what's changed and be able to compare these things and standardize like when something happens, and be able to like backtest and do other kinds of things on previous versions of stuff, because it's always going to change. You're always going to find something new. You're always going to find a bug in your model, but you need to be able to trace it and figure out how to change it.
I love that. That's absolutely fascinating use case and fascinating story as well. Thank you so much, Jimmy. Abe, I'm wondering if you could share a war story, or maybe just some story that you've heard.
So let me be the data person for a minute, partly because I'm going last. I feel like these two examples are like really good real world textured examples. So this isn't a specific thing, but back when we had in-person conferences, when I was just starting to kind of like evangelize Great Expectations, one of the questions that I'd ask in the room, and this is mostly data scientists and analysts, so like some machine learning, but also a lot of kind of like dashboarding, warehouse, that type of stuff. The question I'd ask is, okay, show of hands, close your eyes if you don't want to see, but who in this room has a story about the day that the dashboard broke, and somebody got mad about it, and like all the hands would go up. So like if we were in person, the question I'd like to ask, and actually, Matt, Jim, I'll put this to you in just a minute, is who has a story about a time when you discovered that the model was doing the wrong thing, or the model had been doing the wrong thing without you knowing it? And so one of the things I'm noticing in Matt, your story, is this was still during experimentation, right? Like the sensor model that you were describing hadn't gone live yet. You were still kind of in the discovery process. So you like kind of caught that one up front. But Jimmy, when you're in your story, it sounds like that model had been live for a while, and some of the upstream dependencies had changed. And it was like, do you have some notion of how long had elapsed while it was doing that?
Yeah, thankfully it was kind of a sort of innocuous error in some ways. It was it was still getting dates right. I mean, it may have affected downstream NLP tasks and stuff like that. But if I had to guess, like, I mean, there were multiple releases likely where that oddity was in the model. I'd have to think to put a number or like an actual time frame on it, but yeah.
Yeah, I mean, just from what I've seen, I guess I'll, without naming names, I've now met 3 teams that have talked about deploying a model upside down. So the data science team, figured out a predictor, and then when it was deployed in production, the way it was deployed was picking not the best cases, but the absolute worst cases and recommending them. And like the time to detect that was weeks to months, just before somebody really, really noticed. And I suspect that happens more and people just don't talk about it. But again, it's messy. It's the Wild West still.
It's a pretty embarrassing situation for sure. I admit.
Well, and I'll say, just like to get into the emotional side, like having been the person building those models, not the 3 to my knowledge, I have not actually deployed a model upside down, but it's partly because I have the benefit of being both data scientist and data engineer, and it's less like when you deploy your own stuff. But I've definitely been in the case of like running analysis that I discovered later was wrong, and sometimes like pretty fundamentally wrong, because I'd made assumptions about the upstream data. And just that sinking feeling that you get when you realize, oh, presented this went to the board, the eStaff team, they have now been making decisions on it, and now I need to like walk that back. Even if you're not wildly wrong, even if the end result is only off by a little bit, like I think there's like serious emotional toll in the data community for just those moments of like, oh shoot, I misunderstood what was happening upstream. I made a recommendation, and now that I know better, I have to fix it, but it's going to be really embarrassing.
Yeah, we even had, like with one of my clients, we had a model where they were just finding like customer churn. So the sales department had their own version of churn, which was, hey, this is the customer fulfilled these criteria. And then the marketing department had their own version of churn. So the marketing department was using the model that was based off the sales department and was wondering for I think 4 months, why their leads weren't coming through and why these people that they were recruiting were churning. And it turned out that the sales was like, hey, ours is working. But marketing had lost like so much time because they were starting to structure all their remarketing campaigns based off what sales definition of a churn was. So they ended up pouring, I don't know how much, 10, 20K into Google ads off these parameters. And it was a mess because then you had to throw out all that data and then start to redefine that and then write all the documents all over again to specifically say out what is churn for marketing, what is churn for sales, and then recommendations on what to build a model that works for each for the parameters.
I absolutely love that. Some great work stories. Just for a little bit more clarification, Abe, when you say deploying a model upside down, just talk to us about what that means. I don't think I quite grasp that. Again, I'm not that smart of a guy.
No, I'm using non-standard language there. So make it simple. Imagine it's a regression model, and let's say it's a ad targeting algorithm, just for the sake of things. So high means yes, this person is likely to click through, target the ad to them. Low means don't. When I say upside down, what I mean is when the model was deployed, the results that were giving were all the low ones. Like it was specifically picking the worst potential customers, or one of these was actually medical applications, like the worst patients for a specific thing. So
that's detrimental.
It's crazy. And it's the sort, going back to this whole domain knowledge and repeatability, it's what happens when you make a thing very repeatable, but there wasn't quite enough domain knowledge going into the sanity checking of it. It was built and deployed and rolled out.
Awesome. Thank you so much for giving us an example of that. So I know we did start a few minutes late due to my technical difficulties. We're running up short on time. Are you guys good to go another few minutes past the hour? Is that okay with y'all?
Sure.
I could go 5 past, and then I do have a hard stop.
Perfect. Yeah. All good. So I guess we'll start with Abe on this one. I was wondering if you could share maybe your number one tip for what to do when our data doesn't meet our expectations.
Again, it depends on context, right? Like, but I can lay out the options, right? One is, you just expected the wrong thing, and so you need to update your expectations. So like, you have been surprised, you learn, you adjust. That's one option. Another option is you realize that your system is doing something wrong, right? Like that there's a part of the data system that's under your ownership. And I think a lot of the discussions we've had just over the last few minutes have been your data system had assumed something about the world that turns out to not be right. So you need to now change your data system to adapt to that. That's also an option. There's a third option, which people don't talk about very much, but like actually happens more than you might expect, which is you stop trusting the data and just make the decision based on gut. And that happens a lot. And I think as data scientists and data engineers, we have the tools to dive back in, fix the problem, figure out what went wrong and then readjust. But when you look at what happens in organizations, a lot of the time the decision just has to move on. And so the actual outcome is the data doesn't get trusted, and you just have to kind of get back on the bus the next time it comes. So it depends, right? Like,
yeah. That's pretty much standard answer for anything in data science and machine learning. It depends, because everything is so highly context specific. So kind of changing directions here. I'd love to get you guys' perspective on this shift towards data-centric AI and how that will impact our workflows, if at all. We'll start with Jimmy, then we'll go to Matt and Abe.
Yeah, I'm actually a huge fan of it, a huge proponent of it. It obviously comes with different considerations, because the algorithms have kind of always been like the sexy component, but it's a garbage in, garbage out sort of situation. Like if you don't have good data, then it doesn't matter how good your algorithm is most of the time. So I'm very much a huge proponent of it. Like I think I've written some blogs on the topic as well. But then it becomes a situation where as soon as you start putting more emphasis on the data, very much in Abe's camp, I think, like you have to start testing things. You have to know how the data is changing, how it's moving. You can't sort of just ad hoc, sloppily make changes to your data and do it without without like looking back. I mean, same in software. Like you have to kind of set yourself up for iteration, or start with iteration in mind, and then figure out how you deliver something that's like versioned along the way, and where you can reproduce the things that you've gotten along the way, with those probe points and the way a way to kind of debug your data. Because as soon as you introduce data as an iteration, then you have bugs in your data, just like you have bugs in your code. And so debugging data bugs is more difficult. And so I think it's the right thing to do, because we're 100% dependent on our data with our algorithms. But we also have to also think about the implications that it has, and how we actually approach some of these other problems that are going to come with it.
Thank you, Matt.
Well, I mean, I'm coming from more of like a documentation and like explainability perspective. So I find what you're talking about, Jimmy, really interesting. We should probably connect on that later. But
Yeah.
As far as it comes from like a documentation perspective, it comes to the point of opportunity cost. So there's a trade-off. Like, are you going to like make this ponderously long document, which I have, I'm guilty of that, or what are you going to, or is it going to be like a high level overview that stakeholders can look at and say, okay, this is the rough outline of this. And it's enough for them to come to a stakeholder or a software or a subject matter expert, or even a data analyst or scientist, and be able to go with them with the right questions, and they can go into further detail for it. So explainability, data-centric AI, I feel like shouldn't be like a black box, but when it comes from a governance perspective, should be at least be able to explain what the AI or the algorithms are doing, and also be able to explain what data goes into there. And not only that, but how it's transformed, and in a way that's accessible, understandable to most people in the business pipeline.
Thank you so much. And Abe, I'd love to get your perspective on this shift towards data-centric AI.
I honestly don't see it as that much of a shift, or I think it's a shift in what's getting emphasis. But I mean, you can go back to like 10 years, and Peter Norvig and the Google team were saying more data beats better algorithms. And then I don't know if Monica Rogati was my boss at Jawbone, and I just love her take on things. And her take is clean data beats more data beats better algorithms. And like, so I think that's been sort of on record and kind of understood by practitioners for in a better part of a decade at this point. When I think like what's really happening now that's different, it feels more like we're kind of like building up the institutional knowledge and the tooling to make that real. And kind of getting used to the idea that like, okay, yes, algorithms are going to be researched by a small number of people and then reused in lots and lots of different places. And what you really need is kind of appropriate data for specific use cases, whether that's kind of training best-in-class models that can also be reused, or whether it's building out predictive models in the context of a specific business or organization where like the data is unique to that organization. So to me, it feels like we're sort of, as an industry, catching up with first principles that we've known for a while, and that's just playing itself out.
Hey, thank you so much. Everyone, Matt, Abe, Jimmy, thank you guys so much for taking time out of your schedule to join us for this panel discussion today. I hope the audience took away a lot from this. There's a lot of great nuggets here, a lot of great insight. Again, thank you guys so much. I really appreciate you taking time out of your schedule to be here.
Yeah, thank you.
Yeah, this has been really fun. I'm glad the audio came through in the end.
Yeah, same here. I've got to figure out what's going on with this microphone, because I need this thing. Guys listening at home, look, this is recorded. It'll be on YouTube on the Comet ML channel in the next day or two. So if you're just joining the tail end of this live, don't worry, it'll be up for you to watch. Thank you so much for joining us. Stay tuned. Next week, we've got another panel discussion with some awesome industry experts. We're talking to a few different principal level data scientists. We got Shantanu Tully, we got Susan Shu Chang, and we've got W. Ronnie Huang. We're going to be talking all about the experimental process of machine learning. So experimenting with different algorithms and how to build models and experiment like the pros. So be sure to tune into that. Don't forget to also join us on YouTube, where we've got hands-on sessions led by my colleagues Drew and Michael. That'll be code examples, just taking everything that we've discussed and talked about, but seeing it all in action, so you can connect the dots. So be sure to check that out. My friends, remember, you've got one life on this planet. Why not try to do something big? Cheers, everyone.